Ever wonder how a tiny pill can fix something as powerful and important as the human heart? Well, today we're going to pull back the curtain and look at the incredible science that keeps our most vital organ ticking.
And here it is, the absolute powerhouse of the body. This amazing muscle, the myocardium, it just contracts nonstop, day in and day out, pushing life-giving blood to every single one of your cells. I mean, it's a total hero, but you know what? Even heroes need a little help sometimes.
So, to really get our heads around how these different heart medicines work, let's use a simple analogy. I want you to think of your heart not just as a muscle, but as a high-performance house. And this house, it has 3 critical systems that have to be running perfectly all the time.
Okay, so what are these systems? Well, first, you've got the pump. That's the heart muscle itself. Then you've got the plumbing. Those are the coronary arteries that feed the pump. And finally, you have the electrical system, the wiring that tells the pump exactly when to squeeze. Now, if any one of these systems goes on the fritz, that's when you're in for some serious trouble.
All right, let's dive into problem number 1. What happens when the pump starts to fail? Medically, we call this heart failure.
So what exactly is heart failure? It means the heart muscle itself has gotten weak, or maybe it's stretched out, and it just can't push blood around the body effectively anymore. It's kind of like a water pump in your basement that's lost its pressure. Yeah, it's still running, but it's not really getting the job done, you know?
So how do you fix a weak pump? You call in a specialist, right? And in the world of medicine, that specialist is a really old but super effective class of drugs called cardiac glycosides. Believe it or not, they originally come from the foxglove plant. The most famous one, the one you've probably heard of, is called digoxin.
And what's so cool about digoxin is that it's a triple threat. It tackles 3 things all at once. First, it directly makes the muscle squeeze harder. We call that a positive inotropic action. Second, if the heart's beating way too fast and just wasting energy, digoxin slows it down to a much more efficient pace. That's a negative chronotropic action. And third, it kind of smooths out the electrical signals so they don't get all chaotic, a negative dromotropic action. So what's the end result? You get a stronger, slower, and way more efficient pump.
But, and this is a huge but, here's the catch. Digoxin is unbelievably powerful. I mean, the line between a helpful dose and a toxic one is razor thin. We're talking about a target range in the blood of just 0.8 to 2.0 nanograms per milliliter. To put that into perspective, a single grain of salt weighs about 60,000 nanograms. This is precision medicine at its absolute finest.
And if that level creeps up too high, the body starts screaming for help. You'll see things like nausea, vomiting, a dangerously slow pulse like under 60 beats per minute, and even really weird visual stuff like people seeing yellow or green halos around lights. And this right here is exactly why a doctor has to monitor this stuff so closely.
Okay, so that's the pump. Let's move on to the second system in our heart house, the plumbing. What happens when the pipes start to get clogged up? Well, that leads to a really painful condition called angina.
Angina is basically the heart muscle screaming for oxygen. The coronary arteries, you can think of them as the heart's personal fuel lines. They get narrowed. Not enough oxygen-rich blood can squeeze through. And the result of that is that classic, terrifying, crushing chest pain.
So, you've got clogged pipes? What do? You grab the most powerful drain cleaner you can find, right? In medicine, our version of that is a group of drugs called anti-anginals, and the superstar of that group is the incredibly fast-acting nitroglycerin.
And let me tell you, the effect is almost instant. Look at the before side. You've got these narrow vessels, the heart is working way too hard, and it's starving for oxygen. But then you give some nitroglycerin, and bam! Look at the after. The drug causes what we call vasodilation. It just opens those pipes right up. The pressure on the heart drops immediately, and it gets that flood of oxygen it was desperate for. That's why the pain vanishes so fast.
But here's the question. If you've ever known someone who's had to take nitroglycerin, they'll tell you about one major side effect, a killer headache. It happens almost every time. So, why is that?
Well, the answer is actually pretty straightforward. Nitroglycerin doesn't just open up the pipes in your heart. Nope. It opens up all your blood vessels, including the ones in your head. That sudden rush of blood to the brain is what gives you that signature pounding headache.
All right, so we've tackled the pump and we've cleared out the plumbing. Time to move on to the final system, the electrical. What happens when the wiring in our house gets all crossed up? In the heart, we call that a dysrhythmia.
So a dysrhythmia is really just any time the heart's rhythm isn't normal.
Take a look at this image. This is the electrical signal of one single, perfect heartbeat. See how clean and predictable it is? Well, during a dysrhythmia, this beautiful signal just turns into pure chaos, and that can make the heartbeat dangerously fast, way too slow, or just totally random.
And just like our house analogy, right? When the wiring goes haywire, who do you call? An electrician. And medicine's version of an electrician is a whole diverse group of drugs we call antidysrhythmics.
And a good electrician doesn't just have one tool. They have a whole toolkit. Same thing here. Doctors have 4 main classes of these drugs. Each one targets a different part of that electrical signal to fix a different kind of problem. You've got Class 1 drugs, which work on sodium channels to slow a signal that's just too fast. Then there are Class 2 drugs, you probably know these as beta blockers. They basically tell adrenaline to just chill out. Class 3 drugs, they extend the heart's reset time so it can't fire again too quickly. And finally, Class 4, the calcium channel blockers, they slow the signal and relax the muscle. It's all about picking the exact right tool for the specific electrical problem.
Okay, so we've looked at the pump, the plumbing, and the electrical system. We've seen 3 different problems and 3 different kinds of solutions. But what's the big picture? What's the master plan here? Well, it's all about a coordinated effort. At the end of the day, every single one of these drugs we've talked about is trying to do one thing: maintain a healthy cardiac output. Cardiac output is the master number. It's the total amount of blood your heart pumps out every single minute. It's this delicate dance between how fast your heart beats and how much blood it pushes with each beat. All those different drugs, they're just really sophisticated tools to tweak those factors and keep that final number right where it needs to be.
And that, right there, is the most important thing to remember. These drugs are not just random fixes. They are specific, powerful tools used in a coordinated plan to keep the entire house running smoothly. Your doctor isn't just patching a leak. They're managing the pump, the plumbing, and the electrical to make sure everything works together in perfect harmony.
And this is exactly why it is so critical to follow your doctor's plan to the letter. Every pill, every dose, it's a specific piece of a very complex puzzle that's been put together just for you, all to keep your pump strong, your pipes clear, and your wiring perfectly in sync.
I mean, it's just incredible when you stop and think about it, right? How these tiny little molecules can go in and repair our most vital organ. It really makes you wonder, if we can figure this out, what other incredibly complex systems inside our own bodies are we on the verge of finally understanding and fixing?